From space, Earth looks peaceful. A round blue world covered with clouds and patches of green and brown. You've probably heard this before. Over 70% of Earth's surface is water. The rest, what we call land, is where every mountain, forest, beach, and city exists. About a third of that land is desert. Vast golden plains stretching across continents, like the Sahara and the Arabian Peninsula. For most of our history, sand was just sand. What we didn't know then was that hidden inside those tiny grains is the foundation of modern technology. In 1854, a French chemist named Henri Deville managed to extract silicon from sand. But it was years later, in 1940, when an American physicist named Russell Ohl discovered the p-n junction in silicon, the first real step toward modern semiconductors. But it's not that straightforward. Not all sand is created equal. Most of the sand you see on beaches or in deserts is far too impure. To make semiconductors, you need sand that's unbelievably pure, almost entirely silicon dioxide. That kind of sand exists in only a few places on Earth: spruce pine in North Carolina, Norway, and parts of China. There, miners extract clean sand and ship it to refineries around the world, where it's purified until only pure silicon remains. From there, it continues to Taiwan, South Korea, and China, where the silicon is shaped into microchips. Next, the chips move to Vietnam, India, and China's coastal factories, where they're assembled into familiar devices. They're packed and shipped across oceans once again, to stores and hands all over the world. That same grain of sand, once part of a quiet mountain or a sunlit desert, now powers the systems that shape our lives.